Hello, good morning to Dr. Ding Quang Tiong. My name is Lo Khamun with material number 271566. Today I'm going to present about the discussion and conclusion. I'm going to discuss the question 2, question 3, question 4 and question 5. For the question 2, the question given is what can you say about the effect of the factor and variation in flight distance? What level of each factor will you use to minimize the variation in flight distance? First, changing the location of weights is one of the influence of this factor on the variation of flight distance. Based on the experiments that have been done, our group has observed that the gravity of the different aircraft will affect the flight distance and fall time of an aircraft. When an airplane has a balanced gravity, it will fly a long distance and the fall time becomes long. Second is noise length. If the noise length of an airplane is long, it will be opportunity for the airplane to fly a long distance. In addition, change in wing angle also affect the flight distance of an airplane. Based on the experiment that have been done at the research site, we have observed that aircraft with a wider wing angle have a longer flight distance compared to a less wide wing angle. In addition, stabilizer wings such as up, flat, and down are also one of the factors on the variations of flight distance. After the experiment, our group has observed that flat type airplane wings and down type wings will have the longest flight distance compared to the up-type airplane wings where the flight distance is short. The level of each factor that our group will use to minimize the flight distance variation is the third level. To minimize the flight distance variation, our group recommended by changing the location of weight, noise length, and wing angle. For example, we suggest changing the weight location from A3 to A1, the noise length from C1 to C3, and the wing angle from D3 to D1. These changes that our group is proposing can actually minimize flight distance variation. Next, the third question is in the SN ratio reasonable way to capture both costs to maximize the distance and minimize the variation. Can you specify an optimal design? Why or why not? Yes, the SN ratio is reasonable way to capture both purposes to maximize the distance and minimize the variation. The purpose of this SN ratio is measure the quality characteristic and process analysis of significant thinking parameters. In fact, higher SN ratio values can help to identify control the factor settings that minimize the impact of noise factors. Based on the results of the experiment that have been done, the optimal design that our group proposed is the 6 airplane. The reason our group suggests the 6 airplane is the optimal design because this 6 plane have a long noise length which is C1 compared to C2 and C3. Wing angle is at D2 which is stable compared to D1 and D3. Stabilizer flaps are at B3 or wings that are down type indicated stable and weight position is at A2 more stable compared to the A1 and A3. This has shown that an airplane that has a long noise length and is in stable positions make it possible for the aircraft to fly a long distance and as well as 4 times. Next, the fourth question given is what types of noise variation are considered in this experiment? Based on the experiment conducted, there are two types of noise variation considered in this experiment. The first is physical environment, that is A. In fact, the air in our experiment place greatly affect the smoke flight of an aircraft, namely the flight distance and the landing time of an aircraft. When the air is erratic, it has caused the flight distance and flow times of its discarded plane to be different. As we can observe, the stronger the air, the farther the flight distance of an airplane and vice versa. In fact, we need to take care that there is no wind in the study area so that we can start our experiment. The second type of noise variation considered in this experiment is further plane method. If there is a plane that is further unbalanced, it will affect the smoke flight of an aircraft. In fact, we need to make sure the both sides of the further plane are the same. Similarly, if there is an airplane that is further incorrect or further tries with a different design, it needs to replace with a new fantasy car because the plane that is further incorrect it will interfere flying. The last question given is how can interaction between factors be considered? The first method is to change the wing angle. Based on the experiment that have been done at the research site, we have observed that aircraft with a wider wing angle have a longer flight distance compared to the less wide wing angle, and he has a closer flight distance. The next method is changing the nose length. This nose length actually also affect the flight distance of an airplane. Based on the results of the experiments that have been made, we have observed that the closer the length of the nose of the position of the weight, it causes the wings to be wider the farther the flight distance of an aircraft. But there is the interaction between the factors that can be considered in the Daguchi plane experiment is to change the location of the weight. In fact, the flight distance and flow time of an aircraft are highly dependent on the gravity of an aircraft. This because the different weights will cause the different gravity. For example, the airplane is unbalanced, it causes the aircraft to be really difficult to fly and in turn cause the flight distance is short and flow time is fast. Similarly, when an airplane has a balanced gravity, it will fly a long distance and the flow time becomes long. Therefore, in order to extend the flight distance and the flow time is low, the gravity of an aircraft must be stable. Thank you.